Today in this video, we'll study about chemical equations. Chemical equations. Class 10th, chapter 2. Chemical equations. So in this chemical equation, we'll study what is change, what is matter, and what is physical change, what is chemical change, what is balanced equation, what is unbalanced equation, and how to balance the equation. Okay, these are the things are there in this lesson. Clear? So first of all, what is change means actually? What is change? What is the meaning of change here? Clear? So what is change here? It is the law. Okay, it is the law of nature. Law of nature which occurs in everyday life. Everyday life. Clear? This is called change. Now in this another topic is there matter. What is matter? In lower classes we study this one. Okay, what is matter? So what is matter? You know, it is said to, okay, matter is nothing but it is said to undergo certain changes when energy is added or removed. When energy is added or removed from the matter, from the matter or substance, you can tell. Clear? Matter exists in 3 states. This already we studied. Okay, matter exists in how many states? 3 states: solid, liquid, and gases. Anyway, next one you can say almost all change. Okay, almost all changes taking place in matter may be classified into two groups. Clear? Almost all the changes, whatever the changes are there, it will be classified into 2 groups here. What are the first group called as? The first group called as physical change. First group is called as physical change. Physical changes. In these physical changes, you can write certain points. First point, okay, A. These changes are temporary. These changes are temporary. Clear? And the next one you can say that these changes are easily reversible. Okay. Second point you can write these changes easily reversible. Clear? And third point you can write that here a new substance is not produced. Clear? Here a new substance is not produced. is not produced. Clear? And the fourth one you can write like the physical properties. Okay, the physical properties like the way, okay, the way it looks, okay, and smell and feel, etc. Clear? These are all the physical properties here. Okay, some examples of this physical change. Okay, examples of physical change. What is the first example here? Cutting logs. Okay, cutting logs to make firewood. Good example. Okay, cutting logs, wood. Okay, cutting logs to make firewood. Clear? And second one, falling leaves from a tree. Falling leaves from a tree. Okay, and third one you can write melting of ice. Melting of ice. Clear? These are the examples. Even melting of chocolate also you can tell. Clear? So melting of ice, falling of leaves, and making or cutting a log for firewood. These are all the examples of a physical change. Clear? So this cutting logs here, once you cut here, no, okay, after cutting the big plant, then also you'll get the wood only. If the plant is there, then also it is made of wood only. Same thing, melting of ice. Ice in a solid state when it is in freezer. Okay, but it is in liquid. It is a liquid. It is a water only. But you take out that ice cube outside, keep on in some plate here. It slowly melts. When it melts, 1 second water only in liquid position. If you heat it, it evaporates. If you correct the evaporation, that evaporate water here, no, that also what happens, turns into water. So anyhow, matter exists in 3 stages: solid, liquid, and gases. So these are the physical one here. Glass is there. Glass, if you break the glass here, no, it's made up of glass here. If the pieces, if you collect all the pieces, it is also glass. Clear? So like that. These are physical. The next one is chemical change. Next one is, the second one is chemical change. Chemical changes. Chemical changes. Now, what is chemical changes here? These changes are permanent now. These changes are permanent. These changes are permanent. The first point. And this, or the second, you can tell here, second point, these changes are not easily reversible. Okay, these changes are not easily reversible. Okay, and next one you can tell, the third point here, a new substance is produced here. Okay, a new substance is produced. And fourth one you can tell, physical properties. Okay, the physical properties changes here. Okay, the physical properties change. Clear? If you burn the wood, then what you'll get? You'll get the coal. And if you still burn that coal further, you'll get the ash. And from the ash, you will not get the wood again. Clear? So this is the chemical change. Okay, totally change it will be. Okay, what the substance is there in the first position, it will not be there after the number of reactions. So it is a chemical change. And some examples you can write here. Here example you can give. What is the first example you can give here now? burning of magnesium. Burning of magnesium. Okay, magnesium ribbon. I think in school you have seen, in the lab, I think you have seen the magnesium ribbon. Okay, if you burn this magnesium ribbon is solid state. If it burns, then you will get the magnesium oxide. From the magnesium, you can produce the magnesium oxide, because magnesium ribbon is burning in the presence of oxygen, so it gives the answer. Okay, it gives the result as a magnesium oxide. So totally change. And from magnesium oxide, further reaction, you can't get the magnesium strip again. Clear? So this is the first example. And the second example for this chemical changes is good example, very good example, that is digestion. Okay, digestion of food. Digestion of food. The food takes nearly 3 to 4 hours to digest. Okay, whatever you're eating the food, veg or non-veg here, it takes 3 to 4 hours to digest here. And from digested food, we can't get the 1 second the same food again. Clear? So it is a good example for this. And next, third one, you can tell burning of firewood. Same thing you can take here. Burning of firewood. Okay, burning of firewood to make carbon. To make carbon and heat. If you burn the wood, you'll get the carbon, charcoal you can get here, as well as heat also produce. Clear? And from this 1 second you can't make the wood here. Clear? And the next one is last one, you can tell example here, fourth example, that composting leaves into the soil. Leaves into soil. Into soil. Once you compose the leaves into the soil, making the organic manure, okay, keeping all the leaves inside the soil here for certain days, you can't get the leaves again. Okay, it will be totally changes into sand then. So like structure, manure, like the structure. Clear? So anyhow, this all the changes comes under chemical changes. They are called as chemical changes. Physical and chemical changes. What are the difference between physical and chemical changes? Then these two, if you write, you will get a perfect 4 marks. If it comes under 4 marks, you get 4, 5 or 6. You can get that marks. Clear? These are the difference, physical change and chemical change. Clear? Now what is chemical equation means actually? Okay, what is chemical equation? Chemical equation. So what is this chemical equation means? Clear? So what is the chemical equation? You can write that it is shorthand form. Shorthand form. Instead of writing complete spelling of elements, carbon dioxide, hydrogen, sulfuric acid, sulfur dioxide, many complete spelling, instead of writing complete spelling and this whole thing here, just in short, if you write sulfuric acid, H2SO4, magnesium, Mg, carbon dioxide, CO2, so like it is a short one, so it is a shorthand form. Clear? Represent, what it represent? Okay, it represents the result of a chemical change. Okay, what is the chemical change is taking place here now? We are writing in a short form. So chemical equation, nothing but it is a shorthand form. Clear? So in these 2 points you can write. The first point, always write. Listen carefully. This is very important. Okay, always write the reactants. Always write the reactants. Always write the reactants. That is, okay, substances, okay, which take part in a chemical reaction, on the right side. Okay, remember always here on right hand side. Okay, reactants should be on left hand side. Okay, left hand side. Always reactant should be where you should write here, left hand side. Clear? Left hand side. And example here, you can give one example also, like dilute sulfuric acid. Okay, dilute sulfuric acid, dilute sulfuric acid and zinc, these two are the reactants. Okay, when the zinc added to sulfuric acid, zinc added. This is one example you can give here. Clear? Second point here, what the second point you can write, that always write the product. Okay, always write the products, that is substances formed as a result, okay, as a result of the reaction on the right side. Okay, right hand side, on the right hand side. Clear? Reactants should be at left hand side, and what the product after reaction, the product should be written at right hand side. Left hand side reactants, right hand side products. Clear? Here example you can give, or the example here you can give, example hydrogen and zinc sulfate. Clear? These are formed. Hydrogen and zinc sulfate is formed when in sulfuric acid, if you add the zinc. Okay, if the zinc is added with sulfuric acid, then these are the products. And what is the reactants here? Dilute sulfuric acid, zinc. These are the reactants here. After reaction, what they are giving the product? Hydrogen gas as well as the zinc sulfate. These are the product. So these are the reactants, sulfuric acid and zinc. Hydrogen and zinc sulfate is the product. Dilute, DIL means dilute. Dilute means concentration of water will be more. Clear? It is a dilute sulfuric acid. Concentration of water will be more. If concentration of water is less, then it is said to be as a concentrated sulfuric acid, not dilute one. Clear? So one example will write, equation will write here now. Okay, a chemical equation now. The same thing we'll write in the equation form now. Okay, chemical equation. So how to write this chemical equation now? So what are the two reactants we are taking here now? That you should write. These steps are very, very important. Okay, very, very important. Check each and every line so that at last you can balance the equation. Your own you can balance the equation. Clear? So check each and every step wise so that you can balance the equation clearly. So what are the first step you should write here? Word equation. Don't forget, these are the steps, main steps to do the balancing of equation. So what is the word equation here now? Okay, in word equation you can write zinc and sulfuric acid, isn't it? Zinc plus zinc is added to sulfuric acid. These are the reactants. So when they react here now, what they produce, that is a product. What do they produce? When zinc and sulfuric acid is combined here now, zinc granules combined with sulfuric acid, what they are giving here now? They produce zinc sulfate. Zinc sulfate as well as it also produce hydrogen gas. Clear? These are the reactors and these are the products. Clear? Zinc and sulfuric acid are the reactors. After reaction completed here, they produce zinc sulfate plus hydrogen. This is the word equation. If you write like this, complete spelling, okay, spelling of these elements, then this line is said to be as a word equation. Now the second one, okay, it is called molecular equation now. Molecular equation. Now see molecular equation. What is the molecular equation and what is the symbol of zinc here? Zn. Okay, plus sulfuric acid H2SO4. Because it's a dilute one, you can write DIL. Dilute. DIL means dilute. Clear? Then zinc reacting with sulfuric acid. Then what they are giving here now? Okay, zinc sulfate. This is zinc sulfate. Zinc sulfate. ZnSO4 plus hydrogen also is there, H2. Now this is the molecular equation. Okay, symbols and formula when you're writing here now, it is called molecular equation. How many molecules of hydrogen are present? How many molecules of oxygen is present? How many molecules of sulfur is present? How many molecules of zinc is present? If you are showing like this, that equation is called as molecular equation. If you are writing the spelling completely, it is called word equation. These two are very, very important. Very, very important. Clear? Now I'll show you a balanced equation now. Okay, what is a balanced equation means? Clear? What is a balanced equation? Balanced equation. So what is a balanced equation? So what is the definition of this here? An equation that has an equal number of atoms, of each element on both the sides of the equation. Clear? So what is a balanced equation means? The equation that has an equal number of atoms of each element on both the side. Okay, here also should be equal and here also should be equal. That means whatever the molecules or atoms are present in these reactants, it should be exactly equal. When they produce other one, that also should be equal. The molecules atoms of these elements also should be equal. Both should be equal. So here we can write one line that the mass of the reactants is equal to the mass of the product. Clear? This line is very important here now. Clear? What you written in this line? The mass of the reactants is equal to the mass of the product. Then it is a balanced equation. If both these equations are in this elements, if the molecules are same, that is said to be as a balanced equation. Clear? Now I'll show you how it is a balanced equation. Clear? First you write reactants. Reactants always should be written at left side. Okay, don't forget this one. Always to left side. And then reactants and products should be written always right side. Okay, right side. Clear? This is the left side and this one is the right side. Now what are the reactants we have taken here in this equation? What are the reactants we have taken? Zinc and sulfuric acid. Clear? So write it here now. Zinc Zn plus H2SO4. Clear? Now when these two react, what they produce here now? Zinc sulfate, hydrogen. Clear? Write the product here now. Product right here. Okay. Zinc sulfate ZnSO4 plus H2. Clear? Now here you see clearly what happens here. See in these reactants and products, whether the molecules are same or not, whether the atoms of that elements are same or not. So here how many atoms of zinc is there now? One atom of zinc here, one atom of zinc, Zn, only one atom, clear. And one atom of, okay, one atom of sulfur, clear. See, sulfur also one, only one. Zinc also only one, clear. But hydrogen, see, two, H2, two are there. So two atoms of hydrogen, Now oxygen, you see, O4. That means oxygen, how many atoms are there here? 4 are there here. 4 atoms of oxygen. 4 atoms of oxygen. Hope everybody is understanding this one. Clear? So in this reactant here, I am showing you how many elements are present. 1, 2, 3 elements, whatever the elements are there. In that, how many atoms are there? How many atoms of hydrogen? How many atoms of sulfur? How many atoms of oxygen and zinc? How many elements are there here? 4 elements are there. Total number of elements are 4. Zinc, hydrogen, sulfur, oxygen. Clear? Now see how many, one atom of zinc is present, one atom of sulfur is present. See, sulfur only one, zinc only one, but hydrogen 2 and oxygen is 4. This is the reactant. Okay, in the reactant, these are the atoms are present in these elements. Now, if it is equal in product, then this equation is called as a balanced equation. I will say the balance here, whether it is equal or not. Now see the zinc here, how many are there? One atom of, here also same thing, one atom of zinc, clear. And next one you can find one atom of sulfur, here also one atom here, clear. Zinc also one, sulfur also one here. Now oxygen, you see here, how many oxygen are there? Instead of oxygen, see the hydrogen. Hydrogen how many? 2. So 2 atoms of hydrogen, clear. And how many oxygen is there? 4 atoms. 4 atoms of oxygen. Now see both the atoms here. Okay, the quantity of atoms here and here of the elements, both are same, isn't it? Here both are same. So here you can write. What do you write here? Number of atoms of each elements of reactants are equal. Okay, they are equal now, clear. They are equal to number of atoms of each elements of products, clear. Both are equal here, clear. Both are equal. So this equation is called balanced equation. So at the last you can write therefore the above equation is said to be a balanced equation. Clear? Have you understood here? This is called the balanced equation. Clear? And this everything, okay, reactants should, whatever the elements are present in reactants, atoms which are present should be equal to the product, what they produce the product here. Clear? Understood?